Okay, this is the continuation, page 6, for note 6.5 in Algebra 2. And we're actually going to be doing only 2 problems when we're done here. Page 6 only has examples 15 and 16. But I'm going to develop a formula that's going to help us with that. So we're looking at a question here. What polynomial has the answer 2 minus 5i? Okay. So right here, this is our given answer, and we know automatically when we see that 2 plus 5i, the conjugate version, is also an answer. Now, in general, what you do with these answers when you're doing this is put it in a factor that starts with x minus. So you can see there's 2 of those there set up and ready to go. But I want to show you an example of this. Let's say that your answer was 8, and you put it behind an x minus. Well, setting that factor of 0, it's not real hard to see that you would get an answer of 8 when you do that. So that's the concept of what we're doing. You just put these answers behind that x minus. So our first answer was 2 minus 5i. That's the one they gave us. And the conjugate always works also. So 2 plus 5i. All right, so now we just got to simplify this thing. And we'll find out the polynomial that we need. So we'll start with first times first here. That's going to give x squared. The outside here is minus x times 2 plus 5i. And the inside pair is similar. It's minus x times 2 minus 5i. And then we have last times last here, a minus times a minus, or negative times negative. That turns it to positive, and we have those two terms, 2 minus 5i times 2 plus 5i. So this is precisely the work we're going to try to avoid with the formula I'm going to give you in a minute here. X squared will distribute here, minus 2x minus 5ix, and distribute here, so it's minus 2x again, but this time it's plus 5ix. And down on the end here is 2 complex numbers times each other. So first times first is 4, last times last is minus 25i squared. And then you have a minus or plus 10i and a minus 10i. But there's a lot of stuff here that cancels. Let me show you all of it. These two cancel, and the ones on the ends cancel. And also this here can be simplified. You're going to cross out the I squared and make it plus 25. So we'll simplify here. There's an x squared minus a 4x if you collect your like terms, and plus, well, this down here is 4 plus 25 would be 29. Okay, and you could probably guess that this would be problematic. There's not only a lot of work here, but a lot of places you could mess up. So, dear Mr. Peterson, do you really expect me to do all that work for a single problem? Would you please make a formula that will find the polynomial more quickly? Truly yours, Sad Cat. Okay, so here's my reply. Dear Sad Cat, sure, Mr. Peterson. And here's the work. So I'm doing the same thing, but this time I'm using a plus bi and its conjugate, a minus bi. So let me just kind of rehash what we're doing here. You plug those two answers in behind the x minus. You can see I did that. This part here is your x squared. Outside gives this part. Inside gives this part. And last times last gives that part. Then I distribute here. That gives me these two. I distribute here. That gives me these two. And I do first times first, last times last, outside and inside here. And everything cancels. These 4 cancel. This I squared crosses makes this a plus b squared. You can see that work right there. And I simplified to get a formula that will cut through all of that work. This is what I'm going to call the Happy Cat formula. Totally a random name for it. But it's not a specialized enough formula, or it's too specialized to deserve any real name, so I just nickname it the Happy Cat formula. So you take the x squared. In front of the x, you're going to go minus 2 times the a value, and your constant is a squared plus b squared. So let's get some practice with this. What I've got here is one more example, but we're going to use the formula this time. So the conjugate answer here would be 3 plus 2i. And you can use either one to establish a and b. I'm going to say a is 3 up there, and the b is negative 2. So I'm going to have that the original would look like this, 3 minus 2i, and its conjugate, 3 plus 2i. Now, if I took the trouble to multiply all that out, I'd get this value here. So let's just do that instead. You get x squared. It's always x squared in the front. And you want to double the a value and change the sign. So negative 2 times this number. Put that in front of the x. And then a squared plus b squared. You're going to square this number and square this number and add the results. So I'll just put plus 9 plus 4 there. And we'll simplify that to x squared minus 6x plus 13. That polynomial, if you ran it through the quadratic equation, would have the two answers given, 3 minus 2i and 3 plus 2i. So now we finally turn our attention to the last two problems in the notes. Example 15 looks like this. I've abbreviated a little bit, but these are the zeros that were given to us. So we're going to first set up a place for the original number, the negative 1. Go ahead and put that in there. And then we're going to set up a place for the complex root, 2 minus 3i. And we're going to set up another one for the conjugate of that answer, 2 plus 3i. Now, it's the back half right here that we're going to use the happy cat formula on. But in the meantime, I'm going to simplify the x minus negative 1. Okay, a is 2, and b is 3. Now, it doesn't matter which one you use. You could use this a and this b in the original or the conjugate. So I usually just use the positive version. You're going to have x squared minus 2 times the a value in front of the x. And you can see that's the happy cat formula. And then you go a squared plus b squared. So 2 squared is 4, 3 squared is 9, and we're going to say 13. So negative 2 times the a, that's this part. And this part here is a squared plus b squared. So 4 plus 9. And we're ready to go here. This thing's going to be easy to do now. Just distribute the x all the way down. And then distribute the 1 all the way down. And we got our like terms already lined up here, so I'm just going to get my answer pretty quick here. Set that equal to 0. And you now have the equation whose roots are negative 1, 2 minus 3i, and 2 plus 3i. So you could check each of those. You would store negative 1 and type all that to see if it zeroes out. You could do the same with 2 minus 3i as long as your calculator's in the proper complex number mode. So hit mode and go down to a plus bi before you try to store this one. But it should also, when you type this, zero out. So that's how you can check that one. Okay, example 16 coming at you. And this one has one imaginary and one complex answer. So they both have conjugates. Here's the conjugate of the first one. Here's the conjugate of the second one. Now, the happy cat formula is what we use on that back. But in the meantime, let's set up a place for all of these. X minus 2i and x minus negative 2i. We'll just change that to plus in a minute. And then you have x minus the first complex number and x minus its conjugate. The front half, let's make this a a plus here to save ourselves another line of writing. Okay, that's just going to be x squared. You get canceling values on the outside and the inside. One is 2ix and the other is minus 2ix. And the back is minus 4i squared. We're going to make that positive 4 in a minute. Okay, we're going to put the happy cat formula here with a value of 1 and a b value of 3. So we start out with x squared and then minus 2 times the value of a in front of the x. And then you square both of them and add it. So 1 squared plus 3 squared, 1 plus 9. All right, now you're ready to, well, we got to simplify the front. Cross that out, make that plus. So after I clean it up, it looks like this. And now it's just simply a matter of distributing the x squared all the way down. X to the 4th minus 2x cubed plus 10x squared. And we turn to the 4 and distribute it all the way down. Add our like terms, which are just those center ones. Here's the like terms. Finish off with equal 0. And you've got your equation that had these two answers and their conjugates. And once again, you could check it. For instance, you could store 2i. And if you did that, you would type all that stuff, and it should say equals 0 if you got the correct answer. And the other answers should also check. Okay, so that does it for the last page of the notes. Obviously, this is a difficult section. So you probably want to write down that happy cat formula and maybe memorize it so that you don't have to do all that extra work.